We've done one-step equations. What's next? Two-step equations. So before we go into what that looks like, I want to take a second here and talk about this. What if we had a two-term evaluation to do? Evaluate the expression 2x plus 4 when x is 3. Again, we would realize that we have to replace x, substitute in the 3, parentheses 2 times 3 is 6, because we have to do order of operations, multiply before we add. 6 plus 4 is 10. And when we're using numbers, we have to use our order of operations. And this is 10. So, kind of using that thought process, what if I have 2x plus 4 and I want to know, and it equals 10, and I want to find out that x is 3. I'm using the same problem. Well, over here we use PEMDAS. Alright, parentheses, exponents, multiply, divide, add, subtract to get to 10. If we're going to work this backwards, we have to work this backwards. So when I see 2x plus 4 equals 10, I got to get the unknown by itself. The 2x is the unknown. It has a 2 also, but I have to get rid of plus 4. I can do anything I want, so in this case, I have a plus 4, I'll do minus 4 first, before I worry about multiplying or dividing. And then I get 2x equals 6, because 4 minus 4 is 0, 10 minus 4 is 6, and this is balanced. Now I look at the operation 2 times x. The opposite of multiplication is division. That's a fraction. Divide both sides. And I get x is 3. When we're doing order of operations or evaluations, we go down. But when we have to solve, we have to work from the answer backwards. So I put up examples. That's all we're going to do here today. And I'm going to start from the left, work my way to the right. If you think you got it, you can go. Again, a lot of times we can guess and check, but I want to prove, I want to show through operations each time. So I have 4x plus 5 equals 17. Well, I got to get rid of that plus 5. Start from the bottom of my order of operation rules. And again, here's my balance, right, across each side. Alright, on either side. I get 4x plus 5, they cancel the 5s, I get 4x, 17 minus 5 is 12. Multiplication is shown between 4 and x, I divide. And x is 3. Step 1, step 2. Two-step equation. Over here, negative 5m plus 6 equals 8. I got to get rid of the plus 6. Minus 6. Negative 5m equals 8 minus 6 is 2. There's step 1. I add or subtract first. Now I have to either multiply or divide. Negative 5 times m, the opposite of multiplication is division. Negative 5's cancel. M is negative 2/5. Step 2. Alright, negative 7k minus 4 equals negative 21. Step 1 is to get rid of negative 4. I add 4 on both sides of the equal sign. I get negative 7k equals negative 17. Negative 21 plus 4. And again, if you have to write it out with the arrows, do that. Make sure you get the right value. It's negative 7 times k, I got to do division. They cancel. K equals 2 negatives make a positive on division. 17/7. Step 1. Step 2. I can check any and all of these by simply substituting the value back in. On the first one, 12 plus 5 is 17. I'd say that checks. On the next one, negative 5 times negative 2/5 plus 6 equals 8. Negative negative is a positive. 5's cancel. 2 plus 6 equals 8. Sure enough, that's true. Last one's a little more difficult, but not too bad. 7's cancel. Negative 17 minus 4 equals negative 21. And I would say that checks out. I know all my values are correct. I think the best way to handle it going forward is to pause after. I'm going to do 2 more. We'll go on with the fraction and the decimal, and then you can try the ones after this. There's a few more boards after this. Just because they're fractions doesn't change how we do it. I have to do a 2-step operation. I have to get the variable alone. I have negative half, 1/5 m. So I'm going to add a half. I'm going to get 1/5 m equals. Now, I've got to get a like denominator, so I'm going to write this as 2 fourths and 3/4 and add those, and I'm going to get 5/4. Now I have two operations here. I have 1/5 times m equals 5/4. So I need to divide by a fifth, or I can do anything I want. If I multiply by 5/1, which is dividing, I get m equals 25/4. In the interest of time, I'm not going to plug it back in, but it would work. Over here, I have 0.4x. This has to be alone, so I have to get rid of -2/10. I'll do that by adding 2/10. And again, this is where you got to be careful. I'll get 0.4x. You might have to work on the side. Equals. You have to see you got two operations. Well, I'm going to rearrange that like this over here, so I don't make any mistakes. I get positive 0.04. How do I get rid of 0.4? I'll divide both sides by 0.4. Now this is no fun. Alright, I get x equals, here was step 1, here's step 2. I can't do this. I'm going to have to write this out personally. Move over. I get 4 into 0.4, 0.1. I get the answer is 0.1 for x. And again, this is not, it's two-step operations. It's always the addition and subtraction first. It's always multiplication or division second. We want to do the opposite operation of what we see. So again, two fraction problems. You could pause the video. I'm going to go rather fast here on these. I have to get rid of the 3/10, so I'll add 3/10 to both sides. And just for the sake of writing it a little differently, I'll write it this way. I know half is 5/10. And this is still all part of step 1, because I haven't got an answer here. And I get 2/5 x equals 8/10, which I can reduce that to 4/5. Equivalent operations all the way down. On this side, these are all the same. Half plus 3/10 is 4/5. Now I have 2/5 times x equals 4/5. This time I am going to divide by 2/5, so you know you can divide, which I'll multiply both this by the reciprocal and the reciprocal. These cancel because they're the same. Over here you get 1 on the bottom, and I see I get the 5's cancel. 4 divided by 2, and I get x equals 2. On the other side, I hate mixed numbers, so my first step is to make it improper without doing anything else. I left enough room to do operation over there. Minus 3/7. I see if I want to do this, and again, I'm going to do it horizontal. I prefer horizontal personally. I'm going to multiply by 2 and 2 to get 14. 5/14 minus 6/14. 5 minus 6, negative 1/14. And that is 9/4 x is equal. Alright, now again, I could divide by 9/4, or I could just skip a step and multiply by reciprocal straight out, which is what I will do. Times 4/9 times 4/9. I get x equals, because this becomes 1. Alright, over here I can do some cancellation. 2 and 7. How about negative 2 over 63? And again, if you plug that in and do the operation in your calculator, it would check out. 2 more. Now this time it's a little different on the left problem. You still have to get rid of minus 4 as your first step of your two-step operation. But now, what's happening to the variable? X, fraction of line 3, x divided by 3. The opposite of division is multiplication. And I get x equals 15 times 3 is 45. Now I might want to make sure, so I would take the time to plug it in and see if this works. I might have to do all these operations, right, to make it work out. But it checks out. Last problem here. I have to get rid of 0.4. I get 0.7x equals 0.56. And again, I might jump off the bridge and know this one, but I'm going to make sure and divide it longhand. That was step 1. Step 2 is to do the division. In this case, because it was 0.7 times x, the opposite inverse operation of multiplication is division. And here I'm going to write this out. Over 1 over 1. And I get 7 into 5.6. 0, 8. I almost wrote 8. It's actually 0.8. So I get x equals 0.8. Again, the key here is remembering that we have to do addition and subtraction first with equations because we're working order of operations backwards to find what value works. Keep practicing.